Started recording. Okay, all good. So the context is I have like these four Excel sheet, and each of these four Excel sheet, like for example, let me pull this here. So here I have these four different Excel sheets. 50 with the one is with the miscanthus 55, miscanthus with 55
counties
percentage subsidies. Another one is miscanthus with 100% insurance subsidies. Again 100% miscanthus switchgrass with 100% insurance subsidies, and switchgrass with the 55% insurance subsidies. And out of this, from this four file, each of these four file has like so here we are looking at miscanthus subsidy with 100%, miscanthus with 100% insurance subsidy, and each of these has four different tabs, and each tab has like CDFIPS, optimal choice, acreage, and biomass. So each tab has like four different variables, and I have this. I have excluded this information while I'm importing data. So same thing here and here too. Like for example, if we go all the way up, here it has 8 different tabs, and here all this extra information is here. So I have extruded those extra information. So altogether we are looking at how many 4, 8, 12, 24 different tabs in all these Excel files. So it has 8 different Excel tabs. So I am creating a map, and from here let me show you, and the final product is here. So I'm creating 12 different maps for optimal choices. Optimal choice is one of the variables that you can see in miscanthus production, like 55%. So I have 6 different pages with the 6 each page has 24 different figures. So I have to altogether 72 different figures from like 24 Excel tabs, 72 different variables, and have 72 different figures. So I'm going to deliver this as a final product. And for this, so basically this part is saying I have 3 different PCs that I linked with my computer. So this part is basically saying import your shared working directory. So the key part here is FLs. So here shared working directory Mac PC. Basically this code is pulling this one, so that the whole code is not necessary. It's more complex, but the basic thing is first I said working directory to the Mohit paper, which means this is this to this folder, like all the way. So I copied this link and then put it there. So and here not all these packages are necessary, but I have listed all the packages that I saw while I was collecting different information from different places. And you don't need this, but this is saying in click enter to when you after doing this. So after, if you do this red line, so you have to press enter, and then you'll go to next code. So this is basically pausing in between lines. For this we don't need it. And here
can we ask questions?
yeah,
okay.
Whatever.
So like you have run so many libraries, right? So if we run some or open some library which is not related, unnecessary, will it hamper my analysis?
No,
okay,
not at all.
Okay.
There are some libraries which conflict with other.
Okay.
For example, here you can see deployer filter, max stat filter. So it means basically saying stats another package and deployer is another package. So
Okay.
when you use a filter function, then deployer is enough. And sometimes like if you want to use functions from stats specifically, you can do this stats and then two what is this called, semicolons, colons. So you can use package from stats unless we specifically want to divert to one package or other.
Okay.
Otherwise it's fine.
And these two filters are different?
I haven't tried this.
Okay.
Maybe it may be same, but I haven't tried what is the what, how these two works. And so here I already let me show you my county data. So US Tiger data, US counties. Here you see US counties, and these are some of the save files. So the main important save file here is this mainland USA county.ssp. So you should be looking for something like SSP file, when you want to connect your save file with the your like Excel sheet. So
why
here,
SSP? Like what type of extension or?
so this is a
Yeah.
spatial. So .ssp is a spatial file.
Special file.
Yeah, so in US map you can see different borders, right? State border and the whole country. So even in this map, here you see this outer border.
Mm-hmm.
So this is because this is a polygon. This entire outer border is one big polygon, and you can break this into different states. But I haven't shown that states here.
Mm-hmm.
But that's so this save file has that information. So
Okay.
you are going to you always have to obtain this save file.
Like whenever I want to do some graphs, I have to
Yeah,
have this file.
if you want to make a map,
Okay.
then you need to have a save file
Okay.
that contains polygon information in it.
And this is only for yourself? This
No, you
data?
can find everywhere. Like you can find this data throughout the world.
Okay.
It's available online. You have to Google it. You have to look for it.
Okay.
But it's pretty much available.
So it's available. This file is available in Google.
Yeah, it's available in Google.
Okay.
And for US there is like Tiger Data.
Okay.
So there's a typical website that you can go.
Tiger data.
Yeah, Tiger Database per county. So that's the US government is actively maintaining their database.
Mm-hmm.
So that's the Tiger Data. You can go there. And so I'm basically importing US counties, mainland USA counties.ssp. So this
Okay.
is the SSP file I'm importing.
For counties, right?
For counties, yeah.
Okay.
Read SF, and I set this as a US states, and then so here, and I'm selecting. There may be other variables, but I'm selecting names, state names. So these are the information that I need is that I think would be helpful to preserve in the map. So I'm selecting this information.
And
only.
these all data are available in this file, like the previous file, you know.
Mhm,
Tiger,
yeah.
Tiger.
Yeah,
that-
you have to look for it. For example, if I, you know,
How can I see that what type of variables that file has?
Mm-hmm. Okay, name. This is the
I think
name file.
heads or something.
Names. Okay,
Names
so I didn't
or
have any. I
heads.
didn't have any variable. So let me load this first. Select function load. Okay. So I have already saved all this information in my computer because these files are so long, so big, and it takes so many time to create. So I just created and saved it in my computer, which I will show you. But here, like I think it's not this importing. It should not take a long time. Let's just import this to show how it looks like. So there's US states. So if you do after I run this line, if you do names, US state, you can see all the names available.
Okay.
So
So
that's how-
state name, state abbreviation,
Yeah,
SFIPS,
name, state name, so
county
everything.
FIPS, and geometry.
You can sit come closer.
Okay, yeah, I can see that. What is geometry?
Geometry means it has
Geographical area?
Yeah, it has inform. Hold on, let me see if I can pull this up.
I think in length, yeah, it's like multi.
So
length.
geometry
like
is
north south.
so yeah, it's coordinator.
Yeah, coordinator, yeah.
coordinate.
Ah, okay.
See this polygon? It has like latitude and longitude
Yeah.
information
Yes,
in it.
okay. Mhm.
And once you have this file, and I use this US states, and I filter all only needed states
Yeah,
for
okay.
my study.
Okay.
And some polygon like I get error when I run just this code
Mhm.
because some polygon are not like a really closed polygon, and sometimes that gives error. So I to change that, to remove that error, I make state make valid.
Okay.
So this is a sort of a quality control code, but it's optional. Whether it just depends upon how good your data is. So my data was not good, so I have to fix that.
Okay.
So I run this code,
So
and then
instead of like Tiger data, I can use other data as well.
yeah, or whatever
There are
you
other
want,
datas?
as long as you think data is valid, or
Okay.
as long as data is valid, you can use
I can
whatever.
use- I can
And also it
use-
depends upon what is your objective. For example, if you are just presenting a map, then your your shape or scale may not be very important. But if you are like presenting something and your scale is very important, then you may need more standard data. So it's just depend upon which objective you are, what is your objective. So for my objective, it's just I'm just presenting my data in you as a map.
Okay.
So I
Scale
don't
is
I don't
better.
need a
Okay.
very accurate administrative boundary. You know?
Okay.
Okay.
So that's the goal. And I for this here you can see so AOI state boundary. So this is basically saying I have like 37 different states, each with the boundary, and here AOI global boundary. So this is just one polygon that you see here. So this is one big polygon. So it took me like I think about half an hour to create each of these. So to avoid that part, I'm just like saving all these things. And if you do, after running all this code, if you do like save image and last boundary file, it will save every information in your like here last boundary from data file. So this is the file that I saved. So it's
Okay.
298 MB.
It saves as a what type of file?
R
file?
R file, yeah.
Working file, right?
Yeah, .r data.
Okay.
So you can easily pull it later when you need it. You can easily pull some for the purpose of. But I'm going to make it as a comment, so I don't have to. I won't mess up with my data. So this is basically counting a progress. I'm like setting how much time my code is taking to run. So this is just a kind of time ticker, and so the data that I saved, I just load same data that I saved earlier, and so this code, the whole code part here, it just import an Excel file. So I have like 4 different Excel files, and each has 3 tabs, like 4 to 8 tabs. So I'm exporting this, importing this. So I'm basically creating like a list of files first, and then all this. I'm creating, yeah. So list of Excel files. I'm creating list of Excel files. And this is local file in R, and then I'm creating another empty list file to store Excel file that I input, and also I'm creating another Excel sheet. And here I'm creating a loop from like 1 to the length of list of file, which is 24. If you do this like let's say, let's run this code here. So I load this file. See, it takes some time to load this file, and then if I just run this, it's 4. I have length of this list file is 4, so it has its length is 4. And if you so I'm saying basically from 1 to 4, first create the Excel path, and then grab a Excel sheet name from Excel file, and then set this Excel sheet name to Excel sheet, and using this function, import all the import Excel sheet into this input Excel sheet, and then like after importing each Excel sheet, then I save that as a pool sheet, and then I rename this pool sheet using Excel sheet. Like I rename this this vector here, and then I set this renamed Excel vector to all Excel files, which is I created here to a list. So inside this import function, this part of code is basically telling R to go to Excel sheet and then pull the information, and then here I have changed manipulated variable. For example, acreage 2, I renamed that as acreage, and so this is something you can manipulate when you are changing your modifying your data based on your need. You can do that here. And I import it, and then I save to Excel file, and then I create a list of this is for later use. I create a list of 25 Excel sheet name, and then so this whole code here is just to import Excel sheet. Okay, could not find the Excel sheet, so that means I need to run my okay, and then let's see. There an Excel sheet. Okay. Could not find function Excel sheets. Excel underscore sheets. Okay. That means where is it? Excel. Here, Excel underscore sheet. Okay. Maybe I have to do this. And right after that, okay, I have to close my Excel sheet here and then run it. So it's all good now. So here you can see this. So all of my Excel sheets are everything that comes down to right here. What I did up to here. So everything that comes down to that is saved in the all Excel files. So it's saved as like list of 4, and so it has S1 M100, S3 M100, S5 M100, S7 M100. So there are list of another 8 different Excel tabs, and here list of 8, and then so there are more list of 4. So everything that you saw previously in Excel file is listed, is stored in here. And then after, in all this code right here, I join Excel sheet and then rename. So rename my I join Excel sheet each of those variables to the save file.
Okay.
And then save each of those save file as one file, so I can use that individually. Let's run this. Also, I'll break down this into so all save file here. Here you can see 24 different like save files. This one is one. So you'll have, you see there are like 24 different like elements in here. For that it's a lot complex. So I did a nested loop for one in length of all Excel file. Then I selected this as a temporary save file, and again from this temporary save file I selected single Excel file. So let's say so in Excel sheet there are like one Excel sheet has 4 different tabs, right? So first I selected one Excel sheet, and then I went inside Excel sheet, and then I selected one tab. So and I import all the data from that tab. That's what this part is doing. So temporary data frame, and then I rename those that I rename like if you remember there are like fibs and biomass everything, right? So I created, so and up here I created different variables. So with the muted I created some new variables. So I'm just like recoding them. I'm just renaming them, and then here this part I'm joining Excel sheet with the data frame or the save file. So this temp df, I pulled it from each Excel sheet, and then I left join this temp df to the save file right here, which is study AOI. So this one here is my study AOI. So I have 7. I have like all the counties that are needed for the study area, and I join this with the study AOI, and I basically computed summary statistics for this. This is to figure out basically some calculating summary statistics to know whether my joint is valid or not. So sort of like way of validating information. And here again I'm making another list. So this, and I'm finally renaming this save file based on the name of so there are 24 different data frame, and each Excel sheet has its own name. So I have to give the name of Excel sheet to the data frame, and this is what this code is doing. Name. So this part, that's what it is doing. So it's basically renaming. If I run this part, so this, okay, and if I run this part here, okay. So see, this is calculating summary statistics from. So these are means. Mean of acre is mean of biomass. Mean of acre is 2. Mean of biomass 2. So these are like FOC means like optimum choices for each of these fixed, like how many. So basically it's counting frequency of fixed price or so I'm creating summary statistics, and I did same thing using save file as this is from Excel sheet. Okay, where is my? This is from Excel sheet, and this is from this summary statistics is from save file. So just to validate like my information is right, and this is what like progress bar is doing. So you're basically counting.
It feels really good if you get
yeah.
In R it's very common to get error. So
yeah.
it feels really good.
So when I'm seeing that it's showing like it's progressing,
Yeah,
it's going good. So that
really, it feels really good.
And it gives you a sense of time, like how much it is taking. So
what do you do like when you have big like CSV file, then when it says if you download it you'll be missing some values, then how you save that file? Do you understand what I'm trying to say?
to remove missing variables.
Yeah, for example, if you have the big data set, when you download and try to save it, it says that if you save it, you'll lose some data.
Oh, you mean that's? I think that's in the CSV file. I mean that's just here.
I think that's a warning. I never lose a.
Yeah, you never lose.
I think this is just a warning.
They're just warning.
But I haven't seen my data is lost.
So I know what you're talking about. Look, when you say
you have seen that data is lost.
No, you
just try.
I know what you're saying. Like when you download when you like convert CSV file to Excel or Excel file to CSV.
No, just I tried to save the CSV file.
But it doesn't matter. I mean, they're just warning. I would say make a copy of it, and then save it to another. Just make a copy of it, keep it there, and then play with it. You won't lose any data. So they're just warning. I won't worry about that much.
Yeah, and like in the above there are some options like enable or something. If you don't do those things, sometimes it may show that. But I haven't found like data is lost. But I have seen that warning. I have seen that warning multiple times.
So the fun part is now. So here, first I'm defining a map theme. Like basically, this means like what kind of background and all that. Way I want access, all I want. So I'm defining map theme in the beginning because these are some of the stuff that I want, like pretty much same or common in one map. For example, I want white background, and I don't want coordinates. I don't want like lines on the background. And I don't want like let's say I don't want any axis legend or y or axis legend, so all this thing, and also I want legend to be in a certain position. So pretty much that's common for all maps that I'm going to create. So instead of replicating this code, I'm just creating a maps theme object, and then I'm saving it as a map theme. So when I run this, that's what it does. And so here. This part is basically, if you remember, there are like there is acreage variable in Excel sheet, right? So and here I have all save file. So here I have 24 different elements, right? So from this all save file, I'm pulling one at a time, like S1 M100. It has, like, for example, it has acreage, biomass, and then optimal choice. So I'm pulling one variable at a time to plot this. So this whole code, this entire line will make 24 different maps. So it takes some time to run, and this will make 24 different maps. Here it is, again, it's a nested loop. And now this is not nested loop, so this is just a single loop. So I'm from 1 through length of save file, which means length of save file means 24. Create an object. So I'm basically feeding plotting GOMSF, and I'm feeding DFI, which is this one. So I'm extracting one data frame S1 M100 when I do this for the first time. When I keep it 1 here, when I do 1, then this will pull S1 M100. When I do 2, then this will pull down here as the M100. That's what it is doing. And then so I'm pulling one data frame at a time, and then using GOMSF to plot that data, and here using another GOMSF to plot a global boundary. So here you can see, like, for example, there are two information in here. One is like data on the background, so right here inside, and another one is like this boundary, right? So I'm using two different code to fill the data. So to fill all the information inside, I'm using this line of code, and to plot outer boundary, I'm using this line of code. And this scale field, so this is a different color that I want to put inside, that I want to assign for each values. So if it is continuous, low and high, I put low and high. If it is like a discrete, I have different approach, which I'm going to show. So the name, so this part is shaping this legend right here, this part. So this line of code, also if I land hectare. So if you see this, let's go. Okay, so this is the, so this part right here is shaping this legend. So you can play with it, even right up this part. This entire part is shaping this legend. So I have done this like for acreage, for biomass, and for optimal choice. And here after I create this AC object, and I set this into AC24 maps. So I'm just saving it. I don't think I use this for I haven't used this now, but I'm just saving it for later on if I need to use it. And this is the code to save each of the maps into your local directory. And so here I'm saving each of these maps to this created maps right here. So created maps, and I have 144, but like I have two different versions of 72 different maps. I'm not going to run this whole code because it's gonna take like half an hour. But this whole thing, if you run it, so it will like create a map and then loop through the different 24 different data frame to create a maps. And same code I repeat for biomass. And this and here one thing I change in this two code is like scale field here. This part I have changed it, and like DF it's same. So here biomass, you may have to change this biomass here. Right up here I have acreage and I have biomass, so you may have to change to something different here. And you may want to change something different here based on your variables labels and variables scale. And pretty much same thing, run BM, and if you run this code, you will create 24 different biomass images. maps, and for the this is for categorical data, and these two are for continuous data, and this is for categorical data. For the categorical data, the only the difference you have to do a little bit different approach is to for the scale. Like I did this manually, like breaks. I define my breaks. What are my breaks? I define my values, and I've defined my this part. This part is again creating labels. So this part right here is creating a label from optimal choice. Let's say let's go back to optimal choice right here. That's the part I'm creating using this code, and again saving this each image, individual image to this to created folders, created maps. So I have 70 different maps. So that's the whole part that I did in R, and there's another part I did in LaTeX. Okay, where is my LaTeX file? Okay, so I tried to compile all this my image into like a PDF in R, but that's like it's taking so much time, and it didn't work. So it's basically taking so much time, and also like it's not coming into shape.
Yeah.
So I use LaTeX to compile that, and then just basically using like it's different. Like first you have to, there's a different way to do, and so you have to define all this parameter to set up your LaTeX page, and then begin document, and then right after I put begin figure, and I just put whatever figure I want to put in a list. So when you enter on begin figure, basically here you have you have to tell where your maps are.
Yeah, you have to import that.
Yeah, you have to tell where your maps are. So in R you have to import it, but in LaTeX you just have to tell, go there and look for that. So you have to give it a path, and then begin figure. So this is basically telling organize this figure into, like for example 1, 2, 3, 4. These are on the top 4,
Okay.
middle, and the bottom 4, and I'm putting caption, and then and the label. Basically labeling caption. So creating a figure label each. I compile all those things, and then just select all and run. It should not take a long time.
Very good.
That means, for example, to draw a simple map, you just need to have first trigger data what you have, because there you
Yeah.
have like the FIPS code and what was that other?
So you need a save file.
Geographical what with equator.
Yeah. So you need a
Code.
save file, and save
Yeah.
file all those coordinates, and you need
Coordinates,
some,
yeah.
So that's the coordinate is already there.
Yeah.
If you when you download save file, coordinate is already there.
Yeah.
You don't have to worry about that. But you need a variable that like you did before for your like a paper, COVID paper.
Yeah, okay.
So you need a key to join your save file and Excel file together.
Okay.
So
Oh,
after-
okay.
so
Yeah.
after
We
you-
make on
yeah.
the same
Yeah.
CSV file,
Mhm.
then we run the code.
So then once you have like both common keys to join those
Join.
two files, and then save that as a new save file.
Okay.
And this is a more complicated, more complex task, because I have like
Yeah,
joined
yeah.
4 Excel sheet, and each Excel sheet has several tabs, and
Yeah.
each tab have several
Several
variables.
yeah.
So here using this code, you can pretty much like run millions of Excel files with the millions of tabs and millions of variables.
Yeah.
Now you can automate that, but if you just want to connect draw a map from one Excel sheet with 1 or 2 variables, it's a lot easier. Okay, let's see what do we have here. Yeah, that's it.
Okay. Thank you
Here
very
are
much.
6 different maps. Okay.
So what time for? I didn't have lunch, so
You're going home?
I will go.
It's the day.
Yeah, I'll take like 5 minutes to pray, and then
Okay.